Good day, respectable ladies and gentlemen. I'm Serene, and today I would like to represent my team from University Technology Petronas and Group Technical Solutions Petronas to share our innovation entitled Coupling of Computation Simulation and Hands-on Experience in Process Control Laboratory in line with Industrial Revolution 4.0 oriented education. IR 4.0 is now given significant focus in Malaysia's higher education system. This is to ensure future workers to be highly trained in the emerging technologies, but also as importantly, in the values associated with using those technologies. The incorporation is especially important for process control courses, which involve many automations and computational technologies in actual application. Based on review of published literatures, there has been gradual transition to using computer-aided laboratory due to automation of process control, such as that summarized in this table. It is seen that there has been emerging effort to implement simulation or remote process control laboratory using varying interactive software to provide a more relevant learning experience to students. Looking at majorities of the process control laboratories implemented in higher institutions within Malaysia, they have focused on implementing hands-on practical work supported with digitalization for control and automation. However, component of process control using chemical engineering software has not been commonly incorporated in the laboratory manual. Therefore, based on the review, it is found that most of the laboratory design are confined to computerized simulation environment limited to only one process unit or one transfer function. In fact, this is not reflective of actual industrial processes that are constituted by many interconnected process units to achieve one control objective. In addition, the computerization is mostly confined to only visualization of change in input variables to the control objective. Again, this is not reflective of actual industrial automation processes that can simulate or study interconnection between process variables for design and optimization purpose. Finally, the work is either limited to full hands-on or virtual simulation experience. However, both are important components to enhance students' learning experience. Therefore, the objective of our innovation is to implement a joint computational simulation and practical module design for process control laboratory. In order to achieve the main objective, several actions have been implemented. Firstly, to incorporate process simulation software into course design for process control. Second, to assess improvement in students' attainment of course objectives via performance in laboratory tests. And finally, to assess acceptance of students in a new innovation via quantitative and qualitative feedback. To the best of our knowledge, this is the first implementation within Malaysia's higher institution that couples computational simulation with conventional hands-on laboratory design with equipment and digitalized instrumentations in order to achieve IR 4.0 curriculum as a whole package. The innovation coupling of computational simulation and practical hands-on experience has been implemented in CDB 3062 January 2020 cohort at UTP that involves 180 students. The computational simulation has been incorporated as 15% of the total summative assessment. In addition, the methodology is majorly divided into pre, during, and post-implementation. The innovation couples with course learning outcome of process control laboratory to apply the appropriate sensors, instrumentations, and computational tools to measure physical properties of process variables. So first I would like to start with briefing on the pre-implementation phase. During the pre-implementation, all the available laboratory manuals are reviewed to select appropriate and workable experimental setups that can be correlated with the curriculum of process simulation. Also, functionality and suitability of available process simulators are also compared and contrasted. Finally, ICON has been selected as the computational tool to be employed in this course. The reason has been attributed to its widespread usage throughout varying Petronas operating units, which is at par with many commercial process simulators. Literature review has also been conducted to determine related studies and to analyze challenges in implementation of an IR 4.0 education-based laboratory. Finally, some pre-recorded videos related to importance of process control using simulation tool and workable examples are also prepared for the students at the beginning of the course in order to prepare them psychologically about the new experience. Next is during implementation phase. During implementation, it involves having simulation laboratories to teach students on how to simulate control system using process simulator on top of conventional practical experience. Thereafter, the students are required to simulate the practical laboratories after conducting the conventional hands-on experience as part of their summative assessment. This is an example for a heat exchanger system. The students are also required to report the findings from both simulation and practical laboratories. This exercise is to train the students to acquire critical thinking skills to analyze, evaluate, relate, and discuss the collected real-time data from both experimental observations and simulation work. They are also required to simulate an open-ended project, which involves a daily encountered control system so that students understand its importance, find the relevance, and perceive simulation as a fun and interesting task. Finally, during the post-implementation phase, effectiveness of the innovation has been verified by a post-implementation survey, feedback, and quantification of students' performance in summative assessment. Question related to process control simulation has been included in the laboratory test to gauge effectiveness of this innovation. The performance of students in laboratory tests has been compared to previous semesters since 2016, and it is seen that students' performance in 2020 after implementation of the IR 4.0 oriented syllabus that incorporates both simulation and practical laboratory experience has improved by demonstrating better grades, example, higher number of A's and median, as well as exhibiting least number of failures. Students' attainment of learning outcome has also been improved by demonstrating about 30% improvement or increment in students who score good grades of B and A. This demonstrates the effectiveness of enhancing students' learning experience via incorporation of process simulation and elements that are relatable to the practical laboratory. Exercises from both simulation and hands-on experience are able to assist the students to understand the theory of process control more vividly, given the deep learning thinking process required to set up the simulation. The perception of students regarding the new implementation in CDB 3062 has been collected via survey and feedback, as shown in this figure. In short, most of the students found that the incorporation of process simulation element is helpful to apply their knowledge in process control laboratory. Contribution of the innovation has successfully won silver medal in Teaching and Learning Innovation Festival during October 2020. This innovation helps to prepare graduates for future life and work required by Industrial Revolution 4.0 in this era of digitalization and simulation. It also assists the student to achieve higher level Bloom's taxonomy by applying acquired knowledge from earlier courses in analyzing connections between the theories and practical working solution during setting up of simulation work, as well as training the students to evaluate the limitation of the learned knowledge in addressing actual problems via comparison between experimental that reflects real-life condition and simulation work. In conclusion, An innovative coupling of computational simulation using process simulator and hands-on experience has been implemented in process control laboratory course at UTP, and it is proven a properly designed curriculum is able to improve the students' learning or the students' level of understanding towards the course materials and learning outcome, which is demonstrated quantitatively via improvement in the summative assessment. It also helps the student to prepare them to be well equipped with the skills required by IR 4.0 working environment. Therefore, it is highly recommended to reintroduce or to propose this innovation to all higher learning institutions within Malaysia so that they can comply with IR 4.0 education. Nonetheless, some of the students still find it to be relatively challenging, and this actually emphasizes the importance of early exposure to process simulation tool so that they can accept this new innovation positively. These are the references list, and I thank you for your attention and time in looking at our innovation. Thank you.